3 randomly selected children are surveyed. The ages of the children are 2, 7, and 12. Assume that samples of size n equals 2 are randomly selected with replacement from the population of 2, 7, and 12. Listed below are the 9 different samples. We're going to complete parts A through D. So here are our 9 samples. What we want to do is, for the population, find the proportion of even numbers. Well, the population, if you look here, this is the population. The population is given here, which is the same numbers. It's 2, 7, and 12. We have a total of 3, and how many are even? Well, 2 is even and 12 is even, 7 is odd, so there's 2 of them. So we're going to say, okay, well, let's take 2, which is the even numbers, out of 3. And then that gives us 0.6666 all the way to 7, right? So we want to round this to 3 decimal places, so it's going to be 0.667. So 0.667, and there is our result. Okay, now it says find the proportion of even numbers of each of the 9 samples, and then summarize the sampling distribution of the sample proportion of even numbers in the format of a table representing the probability distribution of the distinct proportion values. So we're just going to open up this data into StatCrunch. Okay, so what we're going to do is the following. Okay, here we have 2 numbers here. Okay, these 2 numbers represent the first pair, right? So here we have 2, and then we have 2. Okay, and then what we want to do is we want to be able to find out what is, how many even numbers do we have. So there's 2 of them, so that means there's 2 out of 2. So 2 divided by 2 is going to give us 1. So therefore, we would say that 1 represents that. So we have 1. Okay, now the next thing is 2 out of 7. So there's 1 out of 2. So 1 divided by 2 gives us 0.5. So 0.5. Okay, then we have the next set of numbers, which are 2 and 12. So that's 2 out of 2. Okay, and then we have 1. Okay, and then we have 7 and 2. So we can see there's 1 out of 2 that's even. So that's 0.5. Here we have an odd number and an odd number, so that is 0 divided by 2. So therefore that's 0. Then we have 7 and 12, so we have 1 even number out of 2, which is 0.5. And then we have 2 even numbers here, so that's 2 over 2, which is 1. And then we have 1 even number out of 2, so therefore that's 0.5. And then here we have 2 even numbers, so 2 divided by 2 gives us 1. Okay, so now what we want to do is we're going to title our column up here, the proportion of even numbers. Okay, so if you see here, I titled this proportion of even numbers because that's what we're looking for. This is the proportion of even numbers. Okay, now StatCrunch doesn't do that. It doesn't give us an option of being able to do that to select the even numbers, so that's why we're doing this somewhat by hand but putting it into the column. Now what we want to do is we want to sort this data in ascending order. So we're going to click up here and select Sort Table in Ascending Order. Okay, so if we take a look here, the first proportion is 0 and there's only 1 of them. So that's 1 out of how many samples, which is 9. Okay, so we're going to say, we're going to pick the 0, and then over here we're going to put in that probability, which is 1 out of 9. Next, you can see that we have 0.5, 0.5, there's 4 of them. Okay, so we're going to go ahead and select 0.5, and then our fraction is going to be, or the probability is 4 out of 9. Okay, and then the next numbers are 1, 1, 1, and 1, and there's 4 of them. So we're going to select 1, and then it's going to be 4 out of 9. Now let's go ahead and check our answer. Okay, so there is our result. Okay, now it says to find the mean of the sampling distribution of the sample proportion of even numbers. Okay, so that means now we're going to come over here to StatCrunch, and then that column that we just created, we want to find the mean of that. So up here, we're going to go to Stat, select Summary Stat, and then go to Columns. And then we're going to select the column that says proportion of even numbers, and then we want to find the mean of that. Okay, so let's select the mean, and then let's select Compute. So here we get 0.6666667. We want to round this to 3 decimal places. So that means we're going to get 0.667, and therefore we get that answer. Okay, now the next question says, based on the preceding results, is the sample proportion an unbiased estimator of the population proportion, why or why not? Well, first and foremost, we can see the following. The mean of the sample proportion of even numbers is 0.667. And then if you notice, that is the same thing as the population proportion. So we can say that the sample means targets the population proportion of even numbers. Okay, so we know it targets. So we can eliminate A because it says do not target, and we can eliminate D because it says it do not target. So it's either going to be between B and C. And now we need to determine whether it's a biased or an unbiased estimator. So what is an unbiased and biased estimator? Okay, so here an unbiased estimator is one that deviates from the true population mean. An unbiased estimator is one that does not deviate from the true population parameter. So therefore, it's an unbiased estimator. So we know that it's going to target the proportion of even numbers in the population. And it says, so the sample proportions does not make good estimators. It's not true, because this one, the sample proportions make good estimators of the population proportion. So we're going to select C, and there is our answer.